In this video, we're going to be talking about blue-green deployment. Blue-green deployment is a technique for releasing applications by shifting traffic between two identical environments running different versions of the application. In a future video, we're going to go through deploying an actual blue-green deployment pipeline, but for now, I just want to spend some time talking about the details. Blue-green deployments can mitigate common risks associated with deploying software such as downtime and rollback capability. In a traditional approach to application deployment, you typically fix a failed deployment by redeploying an older, stable version of the application. Redeployment in traditional data centers is typically done on the same set of resources due to the cost and effort of provisioning additional resources. Although this approach works, it has many shortcomings. Rollback isn't easy because it's implemented by redeployment of an older version from scratch. This process takes time, making the application potentially unavailable for long periods. Even in situations where the application is only impaired, a rollback is required, which overwrites the faulty version. As a result, you have no opportunity to debug the faulty application in place. Applying the principles of agility, scalability, utility consumption, and automation capabilities of the AWS platform can shift the paradigm of application deployment. This enables a better deployment technique called blue-green deployment. Blue-green deployments provide near-zero downtime release and rollback capabilities. The fundamental idea behind blue-green deployment is to shift traffic between two identical environments that are running different versions of your application. The blue environment represents the current application version serving production traffic. In parallel, the green environment is staged running a different version of your application. After the green environment is ready and tested, production traffic is redirected from blue to green. If any problems are identified, you can roll back by reverting back to the blue environment. For example, in this diagram, you'll see on the left side of the diagram that there are two environments, a blue environment which is serving live production traffic, and a green environment. On the right side of the diagram, you can see that the main point of blue-green deployment is the DNS switch from blue to green, so that now the green environment is serving traffic, while both environments still exist. Although blue-green deployment isn't a new concept, you don't commonly see it used in traditional on-premises hosted environments due to the cost and effort required to provision additional resources. The advent of cloud computing dramatically changes how easy and cost-effective it is to adopt the blue-green approach to deploying software. Traditionally, with in-place upgrades, it was difficult to validate your new application version in a production deployment while also continuing to run your old version of the application. Blue-green deployments provide a level of isolation between your blue and green application environments. It ensures spinning up a parallel green environment does not affect resources underpinning your blue environment. This isolation reduces your deployment risk. After you deploy the green environment, you have the opportunity to validate it. You might do that with test traffic before sending production traffic to the green environment, or by using a very small fraction of production traffic to better reflect real user traffic. This is called canary analysis or canary testing. If you discover the green environment is not operating as expected, there is no impact on the blue environment. You can route traffic back to it, minimizing impaired operation or downtime and limiting the blast radius of impact. This ability to simply roll back traffic back to the still operating blue environment is a key benefit of blue-green deployments. You can roll back to the blue environment at any time during the deployment process. Impaired operation or downtime is minimized because the impact is limited to the window of time between green environment issue detection and shift of traffic back to the blue environment. Furthermore, impact is limited to the portion of traffic going to the green environment, not all traffic. If the blast radius of deployment errors is reduced, so is the overall deployment risk. Blue-green deployments also fit well with continuous integration and continuous deployment workflows, also known as CI/CD workflows, in many cases limiting their complexity. Your deployment automation would have to consider fewer dependencies on an existing environment, state, or configuration. Your new green environment gets launched onto an entirely new set of resources. In AWS, blue-green deployments also provide cost optimization benefits. You're not tied to the same underlying resources. So, if the performance envelope of the application changes from one version to another, you simply launch the new environment with optimized resources, whether that means fewer resources or just different compute resources. You also don't have to run an over-provisioned architecture for an extended period of time. During the deployment, you can scale out the green environment as more traffic gets sent to it and scale the blue environment back in as it receives less traffic. Once the deployment succeeds, you decommission the blue environment and stop paying for the resources it was using. When planning for blue-green deployments, you have to think about your environment boundary, where things have changed and what needs to be deployed to make those changes live. The scope of your environment is influenced by a number of factors. For example, organizations operating applications that are based on the microservices architecture pattern could have smaller environment boundaries because of the loose coupling and well-defined interfaces between the individual services. Organizations running legacy monolithic apps can still leverage blue-green deployments, but the environment scope can be wider and the testing more extensive. Regardless of the environment boundary, you should leverage automation wherever you can to streamline the process, reduce human error, and control your costs. AWS provides a number of tools and services to help you automate and streamline your deployments and infrastructure through the AWS API, which you can leverage using the web console or CLI or SDK tools that we've covered in this course. Now, we've already covered most or all of these services elsewhere in the course, or we will cover them in a future video, but I do want to take a moment for each service and tell you how they apply specifically to blue-green deployment. Route 53 is a highly available and scalable authoritative DNS service that routes user requests for internet-based resources to the appropriate destination. Route 53 runs on a global network of DNS servers, providing customers with added features such as routing based on health checks, geography, and latency. DNS is a classic approach to blue-green deployments, allowing administrators to direct traffic by simply updating DNS records in the hosted zone. Also, time-to-live records can be adjusted for resource records. This is important for an effective DNS pattern because a shorter time to live allows record changes to propagate faster to clients. Elastic load balancing is another common approach to routing traffic for blue-green deployment. Load balancing distributes incoming application traffic across designated EC2 instances. Load balancing scales in response to incoming requests, performs health checks against EC2 resources, and naturally integrates with other AWS tools like autoscaling. This makes it a great option for people who want to increase application fault tolerance. Autoscaling helps maintain application availability and lets customers scale their EC2 capacity up or down automatically according to defined conditions. The templates used to launch EC2 instances in an autoscaling group are called launch configurations, and we've covered those in another video in this course. You can attach different versions of launch configuration to an autoscaling group to enable blue-green deployment. You can also configure autoscaling for use with an elastic load balancing load balancer. In this configuration, elastic load balancing balances the traffic across the EC2 instances running in an autoscaling group. You define termination policies in autoscaling groups to determine which EC2 instances to remove during a scaling action. Autoscaling also allows instances to be placed in standby state instead of termination, which helps with quick rollback when required. Both autoscaling's termination policies and standby state enable blue-green deployment. Elastic Beanstalk is a great tool for blue-green deployment because it's a fast and simple way to get an application up and running on AWS. It's perfect for developers who want to deploy code without worrying about managing the underlying infrastructure. Beanstalk supports autoscaling and load balancing, both of which enable blue-green deployment. Beanstalk also makes it easy to run multiple versions of your application and provides capabilities to swap the environment URLs, facilitating blue-green deployment. AWS OpsWorks is a configuration management service based on Chef that allows customers to deploy and manage application stacks on AWS. Customers can specify resource and application configuration and deploy and monitor running resources. OpsWorks simplifies cloning entire stacks when you're preparing blue-green environments. CloudFormation, as we've covered, provides customers with the ability to describe the AWS resources they need through JSON or YAML formatted templates. CloudFormation provides very powerful automation capabilities for provisioning blue-green environments and facilitating updates to switch traffic, whether through Route 53 DNS, load balancing, or any other method. The service can be used as part of a larger infrastructure as code strategy, where infrastructure is provisioned and managed using code and software development techniques such as version control and continuous integration, in a manner similar to how application code is treated. And finally, Amazon CloudWatch is a monitoring service for AWS cloud resources and the applications you run on AWS. CloudWatch can collect and track metrics, collect and monitor log files, and set alarms. It provides system-wide visibility into resource utilization, application performance, and operational health, which are key to early detection of application health in blue-green deployments. And next, I'd like to talk about some techniques you can use for blue-green deployment. While I am going to highlight several specific services in each technique, you may have other services or tools to implement the same pattern, and you should choose the appropriate pattern based on the existing architecture, the nature of the application, and goals for software deployment in your organization. I definitely encourage you to also experiment as much as possible to gain experience for your environment and understand how the different deployment risk factors interact with your specific workload. The first technique I'd like to discuss is swapping the autoscaling group behind an elastic load balancer. This technique uses autoscaling to manage the EC2 resources for your blue and green environments, scaling up or down based on actual demand. You can also control the autoscaling group size by updating your maximum desired instance counts for your particular group. Autoscaling also integrates with elastic load balancing, so any new instances are automatically added to the load balancing pool if they pass the health checks governed by the load balancer. Elastic load balancing tests the health of your registered EC2 instances with a simple ping or a more sophisticated connection attempt or request. Health checks occur at configurable intervals and have defined thresholds to determine whether an instance is identified as healthy or unhealthy. For example, you could have an elastic load balancing health check policy that pings port 80 every 20 seconds and, after passing a threshold of 10 successful pings, reports the instance as being in service. If enough ping requests time out, then the instance is reported to be out of service. Used in concert with autoscaling, an instance that is out of service could be replaced if the autoscaling policy dictates. Conversely, for scale-down activities, the load balancer removes the EC2 instance from the pool and drains current connections before they terminate. This diagram shows the environment boundary reduced to the autoscaling group. A blue group carries the production load, while a green group is staged and deployed with the new code. When it's time to deploy, you simply attach the green group to the existing load balancer to introduce traffic to the new environment. For HTTP or HTTPS listeners, the load balancer favors the green autoscaling group because it uses a least outstanding requests routing algorithm. You can control how much traffic is introduced by adjusting the size of your green group up or down. As you scale up the green autoscaling group, you can take blue autoscaling group instances out of service by either terminating them or putting them in standby state. Standby is a great option because if you need to roll back to the blue environment, you only have to put your blue server instances back in service and they're ready to go. As soon as the green group is scaled up without issues, you can decommission the blue group by adjusting the group size to 0. If you need to roll back, detach the load balancer from the green group or reduce the group size of the green group to 0. This pattern's traffic management capabilities aren't as granular as DNS, but you could still exercise control through the configuration of the auto-scaling groups. For example, you could have a larger fleet of smaller instances with finer scaling policies, which could also help control costs of scaling. Because the complexities of DNS are removed, the traffic shift itself is more expedient. In addition, with an already warm load balancer, you can be confident that you'll have the capacity to support production load. Another technique is updating autoscaling group launch configurations. Autoscaling groups have their own launch configurations, which once again contain information like the Amazon Machine Image ID, instance type, key pair, one or more security groups, and a block device mapping. You can associate only one launch configuration with an autoscaling group at a time, and it can't be modified after you create it. To change the launch configuration associated with an autoscaling group, replace the existing launch configuration with a new one. After a new launch configuration is in place, any new instances that are launched use the new launch configuration parameters, but existing instances are not affected. When autoscaling removes instances from the group, the default termination policy is to remove instances with the oldest launch configuration. However, you should know that if the availability zones were unbalanced to begin with, then autoscaling could remove an instance with a new launch configuration to balance the zones. In such situations, you should have processes in place to compensate for this effect. To implement this technique, you start with an autoscaling group and elastic load balancing load balancer. The current launch configuration has the blue environment. To deploy the new version of the application in the green environment, update the autoscaling group with the new launch configuration, and then scale the autoscaling group to twice its original size. Then, shrink the autoscaling group back to the original size. By default, instances with the old launch configuration are removed first. You can also leverage a group's standby state to temporarily remove instances from an autoscaling group. Having the instance in standby state helps in quick rollbacks if required. As soon as you're confident about the newly deployed version of the application, you can permanently remove instances in standby state. To perform a rollback, update the autoscaling group with the old launch configuration. Then do the preceding steps in reverse. Or if the instances are in standby state, bring them back online. Another technique is to swap the environment of an Elastic Beanstalk application. And this is actually a solution that we're going to automate and walk through in a future video in this course. Elastic Beanstalk enables quick and easy deployment and management of applications without having to worry about the infrastructure that runs those applications. To deploy an application using Elastic Beanstalk, all you have to do is upload an application version in the form of an application bundle, and then provide some information about your application. Based on application information, Elastic Beanstalk deploys the application in the blue environment and provides a URL to access the environment. Elastic Beanstalk provides several deployment policies that you can configure to use, ranging from policies that perform an in-place update on existing instances to immutable deployment using a set of new instances. Because Elastic Beanstalk performs an in-place update when you update your application versions, your application may become unavailable to users for a short period of time. However, you can avoid this downtime by deploying the new version to a separate environment. The existing environment's configuration is copied and used to launch the green environment with the new version of the application. The new green environment will have its own URL. When it's time to promote the green environment to serve production traffic, you can use Elastic Beanstalk's Swap Environment URLs feature. To implement this technique, you would use Elastic Beanstalk to spin up a blue environment. Elastic Beanstalk provides an environment URL when the application is up and running. Then, the green environment is spun up with its own environment URL. At this time, two environments are up and running, but only the blue environment is serving production traffic. As in the diagram, to promote the green environment to serve production traffic, you go to the environment's dashboard in the Elastic Beanstalk console and choose Swap Environment URL from the Actions menu. Elastic Beanstalk performs a DNS switch, which typically takes a few minutes. When the DNS changes have propagated, you can terminate the blue environment. Or, to perform a rollback, invoke the Swap Environment URL again. And the final technique I'd like to talk about in this video is cloning a stack in AWS OpsWorks and updating your DNS. AWS OpsWorks has the concept of stacks, which are logical groupings of AWS resources that have a common purpose and should logically be managed together. Stacks are made of one or more layers. A layer represents a set of EC2 instances that serve a particular purpose, such as serving applications or hosting a database server. When a data store is part of the stack, you should be aware of certain data management challenges. To implement this technique in AWS OpsWorks, you'd bring up the blue environment stack with the current version of the application. Next, you'd create the green environment stack with the newer version of the application. At this point, the green environment is not receiving any traffic. If Elastic Load Balancing needs to be pre-warmed, you can do that at this time. And to reinforce that, take a look at the diagram where you can see two identical AWS OpsWorks environments with Route 53 DNS only pointing to one environment. When it's time to promote the green environment stack into production, update DNS records to point the green environment stack's load balancer. You can do this with DNS flipping gradually by using the Amazon Route 53 weighted routing policy. This technique involves updating DNS, so be aware of DNS issues. In blue-green deployment, there are a few best practices you should be aware of for managing data synchronization and schema changes. Managing data synchronization across two distinct environments can be complex depending on the number of data stores in use, the intricacy of the data model, and the data consistency requirements. Both the blue and green environments need to be up to date. The green environment needs up-to-date data access because it's becoming the new production environment. And the blue environment needs up-to-date data in the event of a rollback, when production is then either shifted back or kept on the blue environment. Broadly, you'll accomplish this by having both the green and blue environments share the same data stores. Unstructured data stores, such as Amazon S3, NoSQL databases, and shared file systems are often easier to share between the two environments. Structured data stores, such as relational database management systems, where the data schema can diverge between the environments, typically require additional considerations. A general recommendation is to decouple schema changes from the code changes. This way, the relational database is outside of the environment boundary defined for the blue-green deployment and shared between the blue and green environments. The two approaches for performing the schema changes are often used in tandem. The schema is changed first before the blue-green code deployment. Database updates must be backward compatible, so the old version of the application can still interact with the data. Or the schema is changed last after the blue-green code deployment. Code changes in the new version of the application must be backward compatible with the old schema. Schema modifications in the former approach are often additive. You add fields to tables, new entities, and relationships. If needed, you can use triggers or asynchronous processes to populate these new constructs with data based on data changes performed by the old application version. You'll need to follow coding best practices when developing applications to ensure your application can tolerate the presence of additional fields in existing tables, even if they're not used. When table row values are read and mapped into source code structures, your code should ignore fields it can't map instead of causing application runtime errors. Schema modifications in the latter approach are often deletive. You remove unneeded fields, entities, and relationships, or merge and consolidate them. By this time, the old application version is no longer operational. There's an increased risk involved when managing schema changes in this way. Failures in the schema modification often can impact your production environment. Your additive changes can bring down the old application because of an undocumented issue where best practices weren't followed or where the new application version still has a dependency on a deleted field somewhere in the code. To mitigate risk appropriately, this pattern places a heavy emphasis on your pre-deployment software lifecycle steps. Be sure to have a strong testing phase and framework and a strong QA phase. Performing the deployment in a testing environment can help identify these sorts of issues early before the push to production. And finally, I'd like to conclude this video by talking about when blue-green deployments are not recommended. As blue-green deployments become more popular, developers and companies are constantly applying the methodology to new and innovative use cases. However, there are some common use case patterns where applying this methodology, even if possible, isn't recommended. There are cases where implementing blue-green deployment introduces too much risk, whether due to workarounds or additional moving parts in the deployment process. These complexities can introduce additional points of failure or opportunities for the process to break down that may negate any risk mitigation benefits that blue-green deployments can bring you in the first place. There are a few scenarios that we'd like to highlight that may not be well suited for blue-green deployments. First, you should consider whether your schema changes are too complex to decouple from your code changes. Is sharing of data stores not feasible in your case? In some scenarios, sharing a data store isn't desirable or feasible. Schema changes are too complex to decouple. Data locality introduces too much performance degradation to the application, as when the blue and green environments are in geographically disparate zones. All these situations require a solution where the data store is inside the deployment environment boundary and tightly coupled to the blue and green applications, respectively. This requires data changes to be synchronized or propagated from the blue environment to the green one and vice versa. The systems and processes to accomplish this are generally complex and limited by the data consistency requirements of your application. This means that during the deployment itself, you have to manage the reliability, scalability, and performance of that synchronization workload, adding risk to the deployment. Another question to ask is, does your application need to be deployment aware? You have to use feature flags to control the behavior of the application during the blue-green deployment. This is often a consideration in conjunction with the inability to effectively decouple schema and code changes. Your application code would execute additional or alternate subroutines during the deployment to keep data in sync or to perform other deployment-related duties. These routines are enabled and turned off, as the case may be, during the deployment by using configuration flags. This practice also introduces additional risk and complexity and typically isn't recommended with blue-green deployments. The goal of blue-green deployments is to achieve immutable infrastructure where you don't make changes to your application after it's deployed, but rather redeploy altogether. That way, you ensure the same code is operating in a production setting and in the deployment setting, reducing overall risk factors. And finally, do you have a commercial off-the-shelf application? And if so, does it come with a predefined update or upgrade process that isn't blue-green deployment friendly? Many commercial software vendors provide their own update and upgrade process for their applications that they have tested and validated for distribution. While vendors are increasingly adopting the principles of immutable infrastructure and automated deployment, not all software products have those capabilities to date. Working around the vendor's recommended update and deployment practices to try to implement or simulate a blue-green deployment process may also introduce unnecessary risk that can potentially negate the benefits of this methodology. And that'll wrap it up for our DevOps video on blue-green deployment. Once more, we will have a lab on this later in the course, and if all of that makes sense, then feel free to move on.